How do angle theorems apply to parallel lines and transversals? Imagine you're looking at a busy street with two long roads running side by side. A line crosses both roads at different points. What do you notice about the angles formed? Let's find out how these angles relate and what rules help us understand their connections. When a line cuts across two parallel lines, it creates several pairs of angles with special properties. These relationships are explained by what we call angle theorems. They help us see how angles are connected and how knowing one can tell us about others. For example, the first important rule is the corresponding angles theorem. It says that if the two lines are parallel, then the angles in the same position at each intersection are equal. So, if you see one angle measure, you automatically know the other one is the same. Next, there are the alternate interior angles theorem. These angles are inside the space between the two lines but on opposite sides of the transversal. When the lines are parallel, these angles are equal. For instance, if one of these angles measures 60 degrees, the one on the opposite side will also measure 60 degrees. Similarly, the alternate exterior angles theorem tells us that outside the two lines, on opposite sides of the transversal, these angles are equal when the lines are parallel. Another key rule is the consecutive interior angles theorem. These are the angles on the same side of the transversal but inside the two lines. When the lines are parallel, these angles add up to 180 degrees. This means they are supplementary, or together they make a straight line. Lastly, the vertical angles theorem states that when two lines cross, the angles directly opposite each other are always equal. This applies at each intersection point of the transversal with the parallel lines. These theorems are not just one-way streets. They also work backwards. If you find that certain angles are equal or supplementary, you can conclude that the lines crossing the transversal are parallel. This makes these rules very useful in solving geometry problems and proving lines are parallel. In real life, these angle relationships help in designing buildings, bridges, and roads. Engineers use these rules to make sure structures are stable and accurate. Architects relying on these theorems to create precise plans. So, understanding how these angle theorems work makes it easier to analyze shapes and figures involving parallel lines and transversals. They give us a clear set of guidelines to see how angles relate and how to prove lines are parallel just by looking at the angles.